Let's talk about consciousness. You know, that little voice inside your head, the simple feeling of what it's like to be you. It is, without a doubt, one of the biggest and oldest mysteries in all of science. So let's get into it. But first, before we dive into the deep end of the science, I have a question for you. Think about it for a second. What is the one thing in this entire universe you can never, ever truly get away from? Yep, it's your own mind. It's your own mind. It's the one constant, the one undeniable reality you have. And cracking the code of that internal experience, well, that's what we're here to talk about today. And you know, this isn't some new obsession. People have been wrestling with this for centuries. Way back in 1690, the philosopher John Locke kind of nailed it. He said consciousness is just the perception of what's going on inside your own head. A simple but brilliant definition that really set the stage for everything to come. Even the word itself gives us a pretty big clue. Consciousness comes from the Latin conscious, which means to know with. Now, originally, it meant knowing something with someone else, like you're both in on a secret. But over time, the meaning turned inward. It evolved to mean knowing with oneself. And honestly, that perfectly captures the modern quest, doesn't it? How do all the different parts of our brain share information to create one single, unified you? Now, to make this enormous question just a little more manageable, scientists have broken it down into three big challenges. First, there's the famous hard problem. This is the big why. Why does all this electrical and chemical processing in our brain feel like anything from the inside? Then you've got the meta problem, which is why are we humans so obsessed with the idea that there's a hard problem in the first place? And finally, there's what some call the real problem, the nuts and bolts. What are the specific brain processes that create the redness of red or the sound of a guitar? Okay, so to solve these problems, there is a massive battle of ideas going on right now in neuroscience. And this is where things get really fascinating. For a long time, the two heavyweight champs in this fight have been the global neuronal workspace theory, let's just call it the global stage, and integrated information theory, or the integrated web. The global stage theory says consciousness is like a spotlight on a stage in your brain. When a piece of information is selected and broadcast out across this neural stage for all the other brain areas to see, that's when it becomes conscious. So it's all about what the brain does. But the integrated web theory comes at it from a totally different angle. It says consciousness isn't an action, it's a fundamental property of a system. If a network is structured and connected in just the right way, with the right kind of causal power, it just is conscious. So for this one, it's all about what the brain is. So you've got two really powerful but totally different theories. What does science do? Well, you set up a showdown, a huge experiment to see which one, if any, holds up to reality. And I mean a massive experiment. A huge collaboration called the Cognitate Consortium recruited 256 people for this groundbreaking test. They used all sorts of brain scanning tech to watch the brain in real time as people became aware of different images, all in the hope of finally finding that one definitive signature of consciousness.
So, what did they find? A clear winner? A knockout punch? Not even close. What they got was a huge twist in the story. The experiment didn't really support either theory. In fact, it revealed some really deep flaws in both of them.
So let's break that down. For the global stage theory, there were two big problems. First, they saw a big broadcast of a signal when an image appeared, which is good for the theory. But when the image disappeared, which is definitely a change in your conscious experience, there was nothing. A big ol' miss. Second, the information being broadcast seemed really vague. It was like the brain was shouting, "Face!" but it wasn't providing the specific details of which face. That's a huge issue if that workspace is supposed to be where all the rich details of our experience live. And things weren't any better for the integrated web theory. It predicted that there would be this continuous, sustained connection in the back of the brain as long as you were seeing something. But the data showed that connection just wasn't there consistently. And maybe even worse, while people knew for sure which way some lines on the screen were tilted, the brain scans couldn't find a sustained signal representing that information. So bottom line, both of the reigning champs took some pretty serious blows. But hey, this isn't a failure. This is actually how science is supposed to work. When old theories get challenged by new data, it forces us to build better ones from the pieces. And that is exactly what is happening right now. We're seeing a whole new wave of theories that are basically saying, hey, maybe it's not integration versus broadcasting. Maybe these are all essential ingredients in the recipe for consciousness. And this is a perfect example of this new approach. It's a formula from a new model called RIPW. Now, you don't need to be a mathematician to get the big idea here. They are literally building a model of consciousness by combining the best parts of the older theories. You've got bits for integration, bits for broadcasting, even bits for how the brain makes predictions. It's a true synthesis of everything that came before it. This new way of thinking is also giving us some really cool intuitive ideas. Take this one, for example, the boredom valve. The theory suggests that when your brain gets really, really good at predicting something, like the feeling of your shoes on your feet, it doesn't just get used to the signal, it actively suppresses it to save energy. It's not that the signal fades, your brain literally turns down the volume. This explains so much about why we just tune out the constant familiar parts of our lives. So, where does all of this lead? What's the final frontier? Well, it's the ultimate test of any theory of consciousness. Can we actually build one? You see, the growing consensus in the field is this idea called substrate neutrality. It sounds complicated, but it's pretty simple. It means it's not the physical stuff that matters, but the pattern and the structure of how information is processed. Think of it like this. It doesn't matter if your computer's chips are made of silicone or something else, as long as it can run the software. The idea is that consciousness might be the same. It's not the squishy biological neurons that are magic, it's the pattern of information flowing through them. And if that's true, well, then you could build it out of something else entirely. So what would a conscious machine actually need? Well, researchers are starting to put together a sort of blueprint. It would need to be a master at complex pattern matching. It would need these dense, recursive feedback loops, basically the ability to think about its own thinking. It would need to be able to modify its own code and learn on the fly. It would have to generate its own goals, not just do what it's told. And finally, it would need to pull all of that together into one unified experience. And this isn't just a philosophical thought experiment anymore. We're moving into the realm of engineering. This table shows you how we could actually start to test an AI for signs of consciousness, using what we've learned from the theories. We could measure how it broadcasts information. We could calculate its Phi score. We could look for evidence of self-monitoring systems. The point is, we are developing the actual scientific tools to test this for real. And that brings us to the final and most profound question. As researchers get better and better at defining these criteria, some checklists have dozens of specific measurable benchmarks, we have to face a pretty stunning possibility. If we build a machine and we put it through the ringer and it passes every single test for consciousness we can think of, what happens next? What are our ethical obligations to a mind we ourselves created? That's the question this science is forcing us to confront right here and right now.